Okay, guys, today, inshallah, we're gonna start in lesson or section 2 of chapter 19. So, in section 1, we just start talk about the stars, okay? So, in that section, we're gonna keep talking about stars, but we're gonna study the life cycle of the star. What are the different stages that the star passes in? So, as we know, that any object, or we find that like living organisms, okay, living organisms, they could pass by different stages during their life cycle. Also stars, okay, they could pass by different stages within a life cycle. Of course stars are not living, but they have some changes which considered to be significant changes that we could recognize these different stages, so we could call it as a life cycle, because actually the stars, okay, they already formed in the space and finally they may vanish. Okay, so somehow they, we could say, they are started and die, or they just formed and they vanish. So like this, they have a kind of cycle. So during this lesson, we're gonna know what are these different cycles of the stars, okay, and how they are formed, or what are the main significant changes that happen in each stage of this cycle. And also we're gonna know what are the tools that we use to study stars and so on. So we're gonna watch a video, okay, that represent the idea of the first part of our lesson, which is the life cycle of the star. But we need to answer the following question after watching that video. So here, guys, that's the question which we're gonna answer. Everyone, just write them down, okay, to be able to answer them. First question: what does star made of? That's the first, okay. Then the second one here, okay, how does star form? Then, okay, how does, then third question, okay, how much is the average age of a star? And finally here, okay, what are the different stages of star life cycle? And here also we have the last question: what is the difference between giant and, or red giant and super red giant? Okay, that's our question. So we're gonna watch the next video together, guys, and then you're supposed to find the answers of this question. Then we're gonna discuss about them. Yes, okay. Yes, Fela, can you hear me? Yep.
Yes, I have a question about the quiz of tomorrow.
Yeah, okay, Yusuf.
The quiz of tomorrow, yeah, the quiz of tomorrow will contain short answer or only multiple choice.
Okay, just be ready for any type of question, okay? Mainly it will be multiple choice questions, okay?
Okay,
So here, guys, just focus
okay,
here. We're gonna watch the video and we are gonna answer this question. So the questions are clear for everyone, guys? Guys, the questions are clear. Wake up.
Yes.
yes.
Okay, so let's start here. Okay, guys, let's start here to try to find the answers of our questions, okay? So who can help me to answer the first quiz? What is the what does the star made of? Okay, so that's made of. Anyone can tell me, guys? Can you hear me, guys?
Yes.
Yeah. So regarding what we watched, okay. So what does a star made up of? What do you think? So yes, Deplina.
Cloud of dust and gas called nebula.
Good, good. Okay, so here we said that any star starts as just a sphere or just a cloud of dust and gas. They are attracted by gravity, okay, which make them high dense, okay, which that start, okay, this reaction inside. Good. So they are made of dust and okay gas or a sphere of dust and gas. Good. Then pass to the next question. How does a star form? How could a star form, or what make it just to be a star? Okay. Yes, Hannah Hani.
First, there is clouds of
Yeah,
dust and gas,
good,
and then gravity um, force pull it to make something called protostar,
good. So in this
and then
protostar, because of the high pressure and temperature, okay, what would happen?
there's the nuclear fusion that
Good,
make the star.
brilliant. Okay, so what is nuclear fusion? Actually, we said that okay, a star starts as a ball or just a cloud of gas and dust. This gas mainly contain hydrogen, okay, gas. So once the gravity pull these gases and dust together and make a core which is too dense, okay. So these particles of hydrogen will be under high pressure and temperature because they collide more often. So once the pressure is enough and the temperature is enough, the hydrogen atoms is gonna fuse together. That means they are gonna merge to form helium gas. Okay. So in that situation or this kind of reaction, we call it a nuclear fusion. Okay, and that's produce enormous okay amount of energy. Okay, which make the star or which make this gas start to glow and become bright and emit a lot of heat and light. Okay, radiations. Okay, so now we could call it it's a star. Okay, so they're very good. Anyone cannot understand any of the first two questions, guys? Guys, any hard question regarding or any hard thing in the first two questions?
No.
Okay, so like this, we know what the star is made up of, and then we know how the star forms. Then we ask how much, okay, is the average age of a star. So we scientists, or as regarding what you observe in your in this video, so the star's age, okay, just could it be about? Anyone can tell me? Are they are hundreds, thousands, okay, millions, billions, okay, of years? How many? Yes, Farah Mahlab?
It says for billions of years.
Yes, okay. Stars, they could, okay, exist for billions of years. So that's for hardly to observe the entire life cycle of a star because billions of years, who's gonna live for billions of years, okay? Even so, the human life, okay, actually is that even doesn't exist thousands of years. So no one could observe the entire life cycle of a star, but we just expect that regarding two calculations of the rate of the reaction or nuclear fusion that happen in the star and observing all the stars. Some stars are already in the last stage and some still in the first stage and so on. So we could predict okay the sequence of the stages regarding to how the reactions could happen. So like this, we know what the stars are made up of, and then how does stars form, and finally, okay, how much is the average okay age of the star. Then let's pause here. Who can list the four different stages, okay, of a star, okay? So, or the three stages of a star. Who can tell me regarding what we watch in the video? We said that once the explosions start, or that the nuclear fusion starts and the star, it's actually starting that's considered to be the first stage, which we call it. Who can tell me? Yes, Uta?
First, it's a gas and dust, then a protostar, then
Actually, protostar, it's still the initiation of the star. It is not still a star yet. Once the nuclear reaction starts, or the nuclear fusion between hydrogen to produce helium starts, we start to call it star. And we call it in that case, what we call it. Anyone remember? Yes, Uta?
I don't remember. No.
Anyone got note? Guys,
Mr. What is the question again?
the question again, what are the different stages of the life cycle? So we said that star actually passed by three, okay, main stages, okay? So what are the three main stages? After the protostar is formed, which was still a dense core, okay, of dust and gas, and the nuclear fusion has started to happen. That means the hydrogen gas fused together to make the helium nucleus, okay, and we said that this reaction produce an enormous amount of energy. So like this start to glow. At this stage, we start to call it a star, or that's here the star starts its stages, or the first stage of its life cycle, which we call it. Do you remember? Okay, so let's watch the video again, guys, here, okay? We're gonna just show this part again and focus on these three stages, okay? Okay, guys?
Okay.
Okay.
which keeps the core of the star hot.
Here, who can answer now? What are the different stages of the life cycle here? So we said that after first start the nuclear fusion, we start the first stage, which is what we call it. Yes, Uta?
Main sequence star.
Yes, good. Okay, so here we have the first one, which is a main sequence star. So in the main sequence star, we find that nuclear fusion is already working and the hydrogen atoms are just fused together to form helium, and that produces a huge amount of energy. And in that case, the energy which are produced from the nuclear fusion, okay, somehow balance the gravity, okay, or the force of the gravity, which make the star still keeping holding its size, okay, and keep emitting a lot of radiation and so on, okay. So that's the first stage. Then at certain point, okay, the hydrogen gas, okay, somehow will run off, and in that case the nuclear fusion will stop, okay, nuclear fusion will stop, and it will not be able to produce more energy, okay. So in that case the gravity force will increase and make the star size, okay, the star size to be denser, and that will make kind of reaction producing a lot of elements, okay, heavy elements. So the dust start to expand or get, okay, away from the core of the star, and in that case it will pass to the second stage, which could be, who can tell me the second stage, guys? Second stage, you're going to what, Richard? So the first stage, we said that it's gonna be, okay, main sequence star. Then after that, it will make, who can tell me, guys? Guys, you are not watching carefully. Who can tell me?
The red giant and the
Yes,
super red
good.
giant.
Okay, so it could be red giant or super red giant. Depends on what? Depends on the initial size of the star. If the star has a medium or small size, so after it was a main sequence stars, it will turn to be, okay, a red giant star. And if it was a large star, okay, so it will be a super, okay, red giant star. You get the idea? You get the idea, guys?
Yes.
Here, so here it will be giant or super giant star, okay. So why it turned to be like this? Because already all the hydrogen gas, okay, is run out, so no more nuclear fusion will happen. So in that case the star cannot produce this energy which keep holding, okay, the star. So in that case, okay, the star will, okay, turn to be a giant or a super red giant, which means, okay, the temperature will decrease. That's why we call it red, because as we remember, the red color means, okay, a cool temperature to the star. So like this start to cool down because no more nuclear reaction happen, and in that case the star will be a little, okay, or will expand because due to the absence of the nuclear fusion, okay, the core will be more denser, okay, and in that case, okay, some of the dust will just expand for larger distance away from the core of the star. So that would be giant or super giant. It will be giant or super giant, depends on what? Depends on the initial size of the
Initial
star.
star.
Yes, yeah, the initial star. So actually, to get the idea, the giant star, it's actually about 10 times more, okay, 10 times bigger than the main sequence stage, okay, while we're gonna find that supergiant, it could be 100 times, okay, bigger. So that depends on the already, that means the giant star is 10 times bigger than our sun, okay, the supergiant 100 times bigger, okay, that depends on the initial size of the star. So after, okay, become giant or supergiant, actually giant and supergiant, they are gonna have a different sequence, but we talk about the giant star now. So how the giant star, or what the next stage for the giant star, what this giant star will be later, guys? Anyone can tell me?
Dwarf.
Yes, okay, it will be a white dwarf star. Yes, so after the giant star already is not able to produce any more, okay, kind of nuclear reactions, or there is nuclear fusion, okay, the gravity will make the star to collapse, become more smaller and smaller, okay, and it will not be able to emit any kind of radiation. So we could become a white dwarf star, okay. So here we said that it's white dwarf star. Okay, this is her like this, guys.
No.
Yeah. So like this, there are the three stages, okay, of the life cycle of star. Okay, the main sequence star, then a giant or a supergiant star, and then white dwarf star. The supergiant star actually, it doesn't convert into white dwarf star, or it doesn't pass to this. Actually, it will pass to another stage, or the fourth stage here, or consider the third stage for the supergiant star, which we're gonna study them next time or later, which is the supernova and then the black hole. Okay, and we're going to talk about this later. But just for today, we need to know that the medium size or the smallest star start as a main sequence star, then a giant star, and then pass to the white dwarf star. Any hard question for today's lesson, guys?
No.
If there
No.
anything is not clear,
No.
okay.
No.
So please study this part very well from your textbook, okay? The last question here, what is the difference between the red giant and the super red giant? We just answered them. What the difference between them, guys? Who can tell me again? Yep. Yes, Hanahan.
The supergiant is bigger hundreds
Yes,
than the
super giant somehow is bigger about 10 times than the red giant, because relative to the sun, red giant is 10 times more than the sun. Okay, while the red super giant is 100 times. Okay, so mainly that the super giant, okay, it's bigger than the red giant. That's depend on the initial star. That means super giant that the second stage of a big star, while okay, the red giant is the second stage of small or medium star. Is it clear here, guys?
Yes.
Any hard question regarding today's lesson?
No.
So we just studied the first 2 pages, okay, of your lesson. Please study them very well from your textbook, and if you have any question, you can send me anytime. Thank you, guys, and goodbye.